Here is the next example. In this example also, he is asking us to find the resonant frequency. As I mentioned, to find out the resonant, or a circuit is going to have a resonant frequency if it has inductor and capacitor in the circuit. So I have inductor here and capacitor here, so we can find the resonant frequency for this circuit. And second important point is, never ever transfer the circuit by using source transformation theorem to find the resonant frequency, because once you transfer the circuit, that circuit is a different circuit, so that different circuit will have a different resonant frequency. So never ever transfer the circuit by using source transformation theorem. Those are the two important points. So now our next step is convert the given circuit into frequency domain. The given circuit is in time domain, so this is going to be 1 over j 0.1 omega. So 0.1 is nothing but, can I write this as 10 over j omega? Keep the j with omega all the time. That's 10 ohms. This is j to omega. So my total impedance, I can clearly see 10 over j omega parallel with 10, which combination is parallel with 2 plus j2 omega. Okay, you always see those errors. Make sure that don't miss that part. j2 omega. I'm just testing you guys how many of you are following, as I always say in the classroom. Okay, so now all these three branches are in parallel. We can clearly see. I'm going to do these two branches once, so I can see, let me label this as zx. So zx equal to 10 over j omega parallel with the 10. It's going to be 10 over j omega times 10 over 10 plus 10 over j omega. So I'll end up with 100 over j omega divided by 10 j omega plus 10 divided by j omega. J omega get cancelled. If I take out the 10, it's going to be 10 divided by 1 plus j omega. Okay, now that zx is in parallel with 2 plus j2 omega. So z total equal to zx parallel with 2 plus j2 omega. So that zx is 10 over 1 plus j omega times 2 plus j2 omega divided by 10 over 1 plus j omega plus 2 plus j2 omega. It's tedious calculation, but please pay attention. If you made a small error, that will escalate and your answer is going to be totally wrong. Okay, now I'm going to solve this offline. So you will see my next screen will have all the calculated values. I'm just want to save some time here. Okay, let me solve this here instead of offline, so you can see every step here. So I have 20 plus j 20 omega over 1 plus j omega divided by 10 plus 2 plus j2 omega plus j2 omega plus j square 2 omega square divided by 1 plus j omega. So all I did, I took the common factor and then I multiplied it. Okay, solved it basically. So these two get cancelled out. I will end up with 20 plus j 20 omega divided by, I have 10 plus 2 12. So j square is nothing but minus 1. So I have 12 minus, so we know that j square is nothing but negative 1 minus 2 omega square. So that's the real part, and imaginary part I have plus j4 omega. Now a little bit difficult part here. To separate the real term and imaginary term, you must eliminate the j part in the denominator. So to eliminate the j part in the denominator, I'm going to multiply this with the complex conjugate of the denominator. So I'm going to multiply this with the complex conjugate. So I have 20 plus j20 omega. It's look like w, it's not w, it's omega. We call that as omega. Angular frequency 12 minus 2 omega square plus j4 omega. Now I'm multiplying with complex conjugate. Complex conjugate is nothing but say z equal to 2 plus j4 and z conjugate, okay, equal to 2 minus j4. Okay, so that's what I'm doing. So I have 12 minus 2 omega square, that's the real part, minus j4 omega divided by 12 minus 2 omega square minus j4 omega. Now in the denominator I have a square plus a plus b and a minus b. I can write this as, in the denominator, a square minus b square. So I will end up with 12 minus 2 omega square whole square. And now so here minus b square, so minus j square times 4 omega whole square. I know that j square is nothing but -1, so I'll end up with positive there. So once I convert this, I'm going to write the denominator one more time. 12 minus j, sorry, there is no j term here in the denominator. 12 minus 2 omega square whole square. So minus j square is nothing but plus 4 omega square. So now I'm going to multiply the numerator. Now, while multiplying the numerator, don't spend too much time multiplying the real parts. All we care for the imaginary parts, okay? Remember that. So now I'm going to multiply this. 20 times 12. I will end up with a real part, so I'm not worried much about that. 20 minus 20 times 2, which is minus 40 omega square. That is also real part, so I'm not worried much about that. And minus j4 omega times 20, so that is imaginary part. Sure, I'm going to multiply and I know exactly what it is, which is minus j 80 omega. Now I'm going to do the imaginary part, j20 omega times 12, so that's a imaginary part, so plus j20 times 12, 240 omega, so that's a plus j. Now j20 times 2, so that's the imaginary part, so sure I need that. So j20 times 2, which is 40 omega cube. Okay, and now it's going to be minus j square 80 omega cube. Okay, so j square is nothing but -1, which is going to end up with the real part. Okay, so as I mentioned, I'm not going to worry about the multiplication. I'm going to keep it as it is, but I'm going to separate the imaginary part on the side. So minus j square is nothing but 1, so plus 80 omega cube. This term is from here. Now I have minus j80 plus j240, so I'll end up with plus j160 omega, and then minus j40 omega cube. Okay, this is your total impedance, Z total. Now I know what is the imaginary part. To find resonance frequency, make imaginary quantity equal to 0. Okay, so I'm going to make the imaginary part equal to 0. So if I make imaginary part equal to 0, I have j160 omega minus j40 omega cube. I don't need to put the j term, so but it's just for your reference to make sure that I'm grabbing only imaginary part, plus 4 omega square equal to 0. Okay, so I can pull out the j and take it to the other side. It's going to be 0, and the denominator I can take it to the other side, multiplied by that, it's going to be 0. So I have j160 omega minus j40 omega cube equal to 0. So when I take this denominator to the other side, multiplied by 0, so I can take out the j term and solve. So we call this as omega naught minus 40 omega cube naught equal to 0, because at resonant frequency, once we make it 0, everything is going to be omega naught. So even I can put omega naught right there for every term. Okay, so now 160 omega naught equal to 40 omega naught cube, omega naught get cancelled out, and 44. So omega naught square equal to 4, omega naught equal to square root of 4, which is 2 radians per second. I'm ignoring the negative term because angular frequency will not have any negative term. Basically, our frequency is number of cycles per second, which is 2 over 2 pi, which is 1 over pi hertz. Okay, and negative number indicates that a frequency is nothing but number of cycles per second. So what does the negative indicate? It doesn't make any sense, or probably it's rotating in the opposite direction. I don't know, but I'm ignoring the negative part. It's just take the positive number. It's going to be resonant frequency equal to 1 over pi hertz. Okay, so as I mentioned, if I convert this current source in parallel with the capacitor reactance into a voltage source in series with the capacitor reactance, it's going to be entirely different circuit. So never ever do that. Thank you.